is 1.6, part 2. We're still going to be solving equations. Last time we did factoring, so we're going to start off with a warm-up of factoring. This is similar to our difference of squares. So in our difference of squares, we take the square root and write it as a minus b, a plus b. So we'll do the same thing here. Square root of x to the 4th is x squared. Square root of 64 is 8. So x squared minus 8, x squared plus 8. But because we're solving, we have to set each one of those equal to 0. So we would say x squared minus 8 equals 0, x squared plus 8 equals 0, and solve each one. So x squared equals 8, x squared equals negative 8, and then of course we have to take the square root of each one of those. So we have x equals plus or minus when we take a square root. Square root of 8 can be simplified to 2 radical 2. And x equals plus or minus, this time we have a negative, so that turns into an I when we simplify. We get 4 answers because it was to the 4th power. And that's one of the things we covered last time. Today we have some solving of rational equations or fractions. So we're going to start by when we have just one fraction on each side. This is kind of a special situation. In this situation, we can cross multiply. But when we do that, you have to make sure you self-impose some parentheses on there. So we'll take 6 times x plus 5 and multiply that, or I'm sorry, and set that equal to 5 times x minus 6. And then we just solve normally by distributing. So 6x plus 30 equals 5x minus 30. Then we'll want to get our like terms together. So subtract that 5x over here, we get x, and subtract the 30 over there, we get negative 60. Now one thing you want to do when you're solving these rational expressions or things that are fractions is we don't want a number that would make our denominator equal to 0, which we talked about back when we were finding domains in our last unit. So you always want to check for extraneous solutions. So I'll write this down so you can remember to do it. Anything that would make our denominator equal to 0 would be bad. We would not want that. So if our answer that we solve for makes our denominator equal to 0, then we would say, we would cross that option out. We wouldn't want it. But negative 60, if we put negative 60 in for any of those x's, it would not make it 0, so negative 60 is just fine. And it would be our answer. All right, let's try another one here. I would recommend on all of these kind of hitting pause to get it written down so that you aren't trying to write down and listen to the explanation at the same time. And then once you get the hang of it, hit pause and try them on your own. But this one you might want to listen to since we haven't tried one yet. Here we are needing an LCD. Since we have multiple fractions on one side, we can't do the cross multiply thing. So we need to find an LCD. LCD is least common denominator, something that all these denominators could divide into. So we look at our numbers. 4 would be the smallest number that both 4 and 2 can divide into, and then x squared would be the smallest variable. What we then want to do is go back to each one of these and multiply it by what it would need to get to that LCD. So 4x, we need another x so that it would be an x squared. So we're going to multiply this whole fraction times an x. This 2x, we would have to multiply by 2 to get to 4 and an x to get to x squared. So we're going to multiply the whole thing times 2x. And then this one, we would have to multiply times 4. It already has the x squared. So we multiply this last one by 4. So when we do that, we end up with 3x over 4x squared minus 4x over 4x squared equals 20 over 4x squared. you'll notice that all of those denominators are the same and they're all the LCD that we found. When they are the same, we don't care about them anymore, so you can get rid of them. So really the equation that we have here is simply our numerators. 3x minus 4x equals 20. 3x minus 4x is of course negative x. So negative x equals 20, and we'd have to divide both sides by negative 1 to get x equals negative 20. We want to double check to see if it would make any of our denominators 0, and negative 20 would not, so that is an acceptable answer. All right, let's try another one like that. So we have multiple fractions. Pause it, give yourself a chance to write it down, and then come back because we need to find the LCD. So before you can find an LCD, all of your denominators need to be fully factored. We didn't have to worry about it on the last one, but this one, we have a denominator here that has a GCF. So we need to factor out an x before we can locate the LCD. So the LCD looks like it's going to be x times x plus 2, because that incorporates this x plus 2, and then the whole thing together as well. Just like last time, we want to multiply by what it doesn't have. So this first one doesn't have the x plus 2, so we're going to multiply it times x plus 2. The second one doesn't have the x. And the last one has both, so we don't have to multiply it times anything. So we'll take that first one, 3 times x plus 2, and it would be over x times x plus 2, that LCD, but if you remember from the last one, all of our denominators are going to eliminate, so we don't even have to write them there anymore. So we have 2x equals 4, and then we just solve normally. 3x plus 6 plus 2x equals 4, which simplifies to 5x equals negative 2. So when we divide by 5, we get x equals negative 2/5. We want to check to see if it makes any of our denominators equal to 0, and we substitute it back in, and it does not, so it's okay. All right, so this last one, I want you to try on your own. So give yourself a chance to write it down, then make sure all your denominators are factored, then find an LCD, then multiply everything by what's missing from the LCD, and then solve. So kind of lots of steps to think through on this one, but give yourself a chance to try it to see if you're understanding. And then come back and check it. All right, so the first thing I'm going to do is factor. So this x squared plus 5x plus 6 is x plus 3 times x plus 2. My LCD are then those two factors, x plus 3 times x plus 2. I'm going to go through and multiply by what's missing. So I'm multiplying this first fraction by x plus 2, and the middle one doesn't need anything, it already has both. And then this last one, now this is a little tricky, this minus out here, sometimes people forget that, so I would change that to plus a negative 5. But then we're going to multiply it times x plus 3. All right, so when we start doing some simplifying, we have 7 times x plus 2 plus 6, remember we didn't multiply that times anything, equals negative 5 times x plus 3. All of our denominators are now gone. We've cleared those out of the way. So we're just going to distribute and combine like terms. 7x plus 14 plus 6 equals negative 5x minus 15. If we add this 5x over here, we get 12x. We take the 20 and subtract it over there, we get negative 35. So then we divide both sides by 12, and x is negative 35/12. We want to see if we can reduce that at all. Is there anything common between 35 and 12, any factors? And there is not. We also want to double check to see if negative 35/12 makes any of our denominators 0, and it does not. So that is our answer. Okay, so anytime you have rational exponents, remember that process of factoring the denominators, finding the LCD, each term by what's missing from the LCD, and then simplifying.